A new way to 3D print concrete can absorb and trap nearly 40% more carbon dioxide than traditional 3D printing methods. It is among ways scientists are exploring to decarbonise cement manufacturing, an industry that's responsible for 8% of the world's carbon dioxide emissions. The new 3D printing process injects steam and carbon dioxide into the concrete mix, directly storing CO2 in the printed structure. Nanyang Technological University researchers say it is not just good for the environment, it is also stronger and more durable compared to regular 3D printed concrete. The scientists hope this can improve construction methods for stronger, more eco-friendly buildings. And joining me now to share more is lead researcher Professor Tan Ming Jen from the School of Mechanical and Aerospace Engineering and the Singapore Centre for 3D Printing at NTU, Singapore. Professor Tan, welcome to the program.
Thanks for featuring our research, Shahida.
Our pleasure. Let's take a closer look at this very interesting innovation, 3D printed concrete that can apparently store and capture carbon dioxide. Talk to us about its unique properties.
So here we are trying to marry the merits of 3D printing, all the advantages like more design flexibility, using less concrete, and also disregarding the use of formwork. So it's a much nicer and more automated way of concrete structures. And we came across carbon capture as an essential development for concrete, so we incorporated into 3D printed concrete and we got much better results.
Okay, I just want to highlight that this concrete here weighs about 7 to 8 kilograms. What's contributing to its weight and how does it capture carbon dioxide within?
What we did was we came across a patent from Aramco where they use steam and CO2 together to cast concrete. And we thought of marrying it with 3D printing. And we believe that because of the greater surface area and more controlled, smaller the chamber that we have, we can infuse a lot more CO2 into concrete. So those are the advantages of actually trying to marry the two technologies.
And part of this concrete mix is also steam.
Yes.
Is that right?
Yes, that's the innovation that we incorporated.
Okay, and on the surface, it looks like a conventional 3D printed concrete, Professor Tan, but the internal composition is very different. So
yes, so we captured CO2 into carbonates. So the end result was this whole structure is 35% stronger in compression and 45%, up to 45% stronger in their flexural strength. So not only it improved the strength, it hardens the concrete much quicker. So in normal concrete, it takes about 1 to 3 months for it to harden before one can move in. So using CO2 also speeds up, not only hardens it, but actually speeds up the hardening process. So a lot of advantages.
Okay, earlier you were talking about how this was from an idea from a patent of Aramco. Talk to us about that. I mean, what made you want to further this technology?
So we came across, we're always looking for ways to use waste and design sustainable concrete materials. And when we came across this patent by Aramco where they could capture CO2 in the concrete, we thought we'd try to marry the two. And I think we can get better results. And the end result was actually a lot more. We got 35% higher concrete capture than just normal cast concrete. So we have a provisional patent pending that's just been granted.
Okay,
yeah.
We'll talk about that in a while. So as we know, concrete is very pervasive. It is widely used in urban built environment. Yet, it is notoriously very carbon intensive. So how will this innovation benefit the construction industry here in Singapore in particular? So
going forward, there's carbon pricing, and that's in the works. Currently, the cost of a ton of concrete is like $25. It's going to go up to $45 in Singapore. So people will be incentivized to capture concrete permanently. So buildings are excellent opportunities to capture lots of concrete by weight, and in that sense also CO2. So if you have incentives, the industry will follow suit. or punitive measures. If you don't use CO2, you don't get grants, you don't get carbon credits. So that's the end result. You can incentivize the industry to put more CO2 into their buildings, and potentially we can put by weight 2 to 3%.
Okay. And the goal here is to essentially make the construction industry greener, more sustainable. But what further development or improvements do you foresee will need to make here to maximize this technology?
You're actually right, because the construction industry contributes about 40% of the CO2 footprint. And just the use of making cement contributes 8% already. So one way is to use less, right? And use recycled materials, repurposing waste materials, be it vegetation waste or recycled materials, recycled concrete, to incentivize improvements in the sustainability equation.
Earlier, you were talking about how you have applied for a patent in the US for this innovation. What is the development to market plan or timeline that we are looking at here?
We just had our provisional patent jointly with Aramco granted. So it's in the process of being granted the patent. So provisional patent already granted. And we hope more people will take on board this innovation to save the earth.
Okay, when do you foresee a concrete with CO2 products such as this one be commonplace in the industry or in our environment?
Okay, we're all part of the same industry, so we are trying to come up with some innovative structures to bring this to the market, and hopefully there'll be players who are interested in taking this on board with incentives to actually capture the concrete.
Okay, we've been talking about how the industry is responsible for about 8% of the world's CO2 emissions here, right?
8% cement and 40% in general with lighting, heating, cooling.
So how much of this innovation could potentially contribute towards the world's global sustainable development goals, you think?
I think every small part plays. Like I say, if you can capture 2 to 3% by weight, that's a humongous amount of CO2 that we can capture permanently stored in buildings. And actually, concrete continues to capture CO2 in its lifetime. So they use carbon dating to see how old a building is. So it's a permanent absorbent for CO2.
Okay.
Alternatively, is to grow more trees and eat less meat.
All right. Professor Tan, thank you so much for coming in tonight to talk to us about this innovation. That was Professor Tan Ming Jen from NTU, Singapore.